everyone, it's Alyssa and welcome to You Can Learn Math. Today we're going to be doing advanced compound interest problems. There was a previous video, link down below, for the introduction to compound interest. That's the ones where you're only compounding annually, one time every year. I went through in that video all the different examples, how to solve for all the different variables. Link is down below. If you're looking for a video on how to calculate interest that is compounded continuously, that will be released very soon. Link will also be down below when it comes out next week. So again, today is advanced compound interest. I'm going to tell you, number one, what the formula is. Number two, why does this formula work? Number three, how to solve for the final amount. Number four, how to solve for the principal. Number five, how to solve for the rate. And number six, how to solve for the number of years. Each of these has a different method, so it's going to make it a long video, but I wanted to show you, to go through and show you all of these different ways how to do them. Right, so first off, and also I'm going to put links down below so you can jump very easily to each of those sections if you have a specific thing you're trying to solve for. Number one, what is the formula? Right, this is it. You may see some slight variation on this depending on your math book, but the same overall structure is intact. It means the same thing. For example, I've seen ones that called this P sub t, and this is P sub 0. I've seen it like P of t. It all means the same thing. Now, what are these variables meaning? First, we have A here. This is your final amount. We're going to be talking about this in terms of money, compound interest as far as like bank accounts and things, making money. So the final amount of money in your bank account, Principal is our P. That is your beginning amount, where you start, your beginning amount. Up here, I'm going to zoom out a little bit because I want to go up and down. Here, this is your rate, and this is the annual rate that they quote you. Our N, I'm going to use blue because there's two of them. We use the same variable twice. N is the number of time periods, let's call it that we're talking about. In every year. T is our years. So the number of time periods, this is when we divide a year up into months or quarters or days. When they're saying in the math problems you're given, this is compounded quarterly, this is compounded monthly, weekly, daily. Then you're saying, okay, if it's compounded daily, how many days are in a year? If it's compounded monthly, how many months are in a year? Whatever that number is, that's what you put in for N. So there's our basic formula. Part two, why does this work? I'm going to move this over here so we can still see it. Just up here, but it's still visible. It's our little reference point. Why does this work? Let's say I had $1,000 that I'm putting in a bank account, and it pays 3% interest that is compounded quarterly. I want to know how much money I'm going to make out of this. How would I set this up? Well, first I'd say quarterly. How many times a year are they putting money in my account? How many times a year are they giving me interest? Quarterly means 4 times a year. So each of those times, are they giving me a full 3%? No, that is the annual rate. It's for the whole year. So they would be giving me 1/4 of 3%, because we've only gone through, so if you're going along through the year, you'd say, oh, if you made it through the whole year, I'm going to multiply by 3%. No, I've only made it through a quarter of the year. So stands to reason you should get a quarter of 3% as your interest. So a quarter of 3%, we can do that mathematically as a quarter times 3%. And 3% can be rewritten as 0.03. And when we multiply by a fraction, we put that over 1. I know it looks awkward to have a decimal in a fraction, but bear with me for now. So there is my rate, 0.03 divided by 4. And if I put this in a calculator, 0.03 divided by 4, I get 0.0075. So I go, okay, how much money do I make in that first quarter? I multiply that by 1,000, and I make $7.50 in the first quarter. But if I wanted the final amount, what is the amount in my bank account, I would say 1,000 plus $7.50. And what have I added together? The 1,000 is the 100% that I started with, and the $7.50 is that 3% divided by 4. When I added those together, I get the amount. So, okay, if I represent this in decimal terms, since I'm replacing 3% with 0.03, I'm going to replace 100% with 1. So that's the rate, and that if I multiply that by 1,000, I'm going to get the amount I make in that quarter. And it's the final, not just, I should say, excuse me, not the amount I make, but it's combining it with that original, so it's the final amount that's in my bank account at the end of that quarter. So if it happens 4 times in a year, I'm going to be multiplying 1,000 by this 1 plus 0.03 divided by 4 times in that year. So when you multiply 1,000 by the same number 4 times, it's like I'm raising it to the power of 4. And what happens if I left that money in that account for 2 years? Well, that's going to be 8 times, right? Or 4 times 2. And as you can see, we have set up a correspondence, corresponding thing to this original formula. Because what do we have? We have $1,000, which is our principal, what we started with. Then, to get the final amount every quarter, we took that 0.03 and we divided by 4. What does our formula say? You take the rate and you divide by the number of time periods that you're using every year, in this case 4. And we put it to the power of, we said, well, it's happening 4 times a year, and what if we did it for 2 years? There's our n again, and there's our t for our number of years. That's why this works. That's where it comes from. Right now, on to number 3. Let's put this in action. And we're going to start with solving for the final amount. This one is going to be the easiest. We're going to go up in difficulty. So here's the problem I'm given. Someone invests $6,000 and it is compounded quarterly. The rate is 3% and they leave it there for 4 years. What is the final amount? Right, all we have to do is plug everything in, and then we start seeing how we need to solve it, because for each of these variables there's going to be a slightly different method. $6,000, that's our principal, so I'm going to put that in here. It's what I started with. It says quarterly. Again, quarterly means 4 times every year. So I'm going to replace that n with 4. said it's 3%. So I'm going to write this in for the rate. Make sure to write it as a decimal, not decibel. And it happens over the course of 4 years. So I replace that t with 4. Now this is just a matter of entering it into our calculators correctly. The order that I would recommend, and this is especially true if you're using just a sort of basic on your phone calculator instead of a scientific or graphing calculator. Start here, 0.03 divided by 4, that's 0.0075, and then add 1. So inside this parentheses is 1.0075. Then 4 times 4 is 16. So use the x to the power of y button on your calculator to say, what is 1.0075 to the power of 16? That gives me 1.12699. I like leaving the decimals in there. It makes it more accurate. And then I'm going to hit times 6,000, and I get my final answer for my final amount of $6,761.95. Again, accuracy and the order that you type things into your calculator is going to make the big difference here. That's going to be the one tricky spot. Okay, second type of problem is going to be when we solve for the principal. So for this one, let's say they tell us the account has an annual interest rate of 4.2%. It is compounded monthly. It's in there for 5 years. And the final result is $9,865.81. How much did the person start with? Another variation of this problem you're likely to see is a hypothetical. They'll say it as, Susie wants to have $50,000 in her account after the end of 10 years. How much should she put in to start? That's another way this may be ordered, or that's another way this may be presented. That may be the language they're using for these problems. Same method in both, just a little different verbiage to look out for. So we're again going to start with our base formula. We plug in everything that's given to us, and then we solve for what's left. First, we have our interest rate, 4.2%. We write it as a decimal, 0.042. It is compounded monthly. There are 12 months in a year, so our N is 12 time periods in the year. It is over the course of 5 years. So my T is 5. And they tell us that after 5 years, this person has $9,865.81. That is their final amount. So I look and I go, oh, principal is the only thing left. And sure enough, the question is, what did they start with? So in our calculator, we're going to go on the right side first, and we're going to simplify this. Just as with the previous one, I would recommend doing this first. 0.042 divided by 12. That gets you 0.035. Excuse me, 0.035. That's a critical difference. And I'm going to add 1 to it. So that becomes 1.0035. All right, so I'm going to write that in here, 1.0035. Next, 12 times 5 is 60. So I'm going to use my calculator and say put that to the power of 60. And that gives me 1.23323. I'm keeping it very long, I know. So that is all of this condensed. I combined the rate divided by 12 with 1, and then put it to the power of 60, and this is what I got. So all that times the principal is equal to 9865.81. Even though there's lengthy decimals here, this is still a pretty standard algebra problem. P is being multiplied by this number, so I'm going to divide both sides by this number. So 9865.81 divided by 1.23323 gives me P of $7,999.98. Because there was some rounding in there, I think it's safe to assume this person started with $8,000. In these sort of problems, depending on what your teacher provides you, most likely, honestly, they'll probably say round to the nearest dollar, in which case you would have $8,000. But be careful. Make sure that you are only rounding in these portions when it tells you to, and that your final answer is rounded either to the nearest cent or dollar. Dollar is most likely and most common in these scenarios. Okay, next one. We are going to solve. We're going to solve for rate. So this one, we're starting with a principal of $2,000. It is compounded daily. Oh. After 3 years, the final amount is $2,401.59. What is the rate? Okay, same thing. We're going to fill in everything that we are given, and then we solve for what is left. First, we are told what the person started with, $2,000, so that's our principal. It's compounded daily. Oftentimes, these problems will specify whether it is a leap year or not, because a leap year has one extra day. It usually will say it's not a leap year. So the number of days in most of our years is 365. So that takes care of our daily, and then we're told this is happening over 3 years. So that's our T. And then final amount, $2,401.59. So let's put that in for our final amount. Now this one's a little different. I don't start here because I don't know the rate. I can't start there. So let's start with this, 2,000. Let's divide both sides by 2,000 to get rid of that. So $2,401.59 divided by 2,000 is 1.200795. And I'm just going to leave it like that just for accuracy. I want this to be as accurate as possible. On the right side, I have 1 plus r over 365 to the power of 365 times 3. I'm going to multiply that. 365 times 3 is 1,095. Now this looks very extreme, but this is a very similar, in the same style, same way of solving it, problem as if I said 9 equals x squared. What is x? You say, I do the opposite of square to both sides. I square root, and then that gives me x. If this were x cubed, what's the opposite of cubed? Cube root to both sides. This, I know this is crazy, but it's the same setup, same principle. Here it's to the power of 1,095. So we are going to take the 1,095th root of both sides. I know that seems ridiculous, but that's what we have to do. Yeah. The button that you're going to look for on your calculator looks like this. So you're going to enter your x, which is 1.200795. You're going to press that button, this y root of x. Then you enter the root, 1095. And you get 1.0001671. I know I'm going way out there, but these are such small numbers that it's going to matter. So 1 plus r over 365. Okay, let me zoom out a little bit and move up. Now this is looking more and more like a sort of standard, quote unquote, standard algebra problem. I'm going to subtract 1 from both sides. And I get 0.0001671 equals r over 365. R is being divided by 365, so I'm going to multiply by 365 on both sides. So times 365 on both sides, and I get that R is equal to 0.0609. So if I'm rounding this to make this like a 5.2 or 3.4%, where you just have that tenth of a percent. To round this, it would be rounded to 0.061 or 6.1%. That's my rate. So yeah, in this case, again, when you're solving for rate, you're going to be using roots, which is in, make this a little, there you go, is in right here. When we're doing these roots, you're going to be taking the root and you're going to use the power to tell you what root to be taking. Now that seems a little more in-depth, a little more complicated than the ones we were doing previously. Yeah, there's no way around it. You have to use that. The last one on the list is arguably the most confusing to a lot of students, and that's when we solve for the number of years. So here is final problem. Someone starts with $10,000. It is compounded quarterly. The rate is 3.8%. The final amount is $13,533.26. How many years was this in the account? Okay, we're going to use our same initial setup. The amount equals P times 1 plus R over N to the power of N times T. We are told the principal, $10,000. That's what he started with. It is done quarterly. Quarterly means 4 times a year. Oops. So 4 is my number of times per year for N. I am told the rate is 3.8%, and I write it as a decimal, 0.038. Lastly, I'm told the final amount, so I put that here, $13,533.26. I'm going to start very similarly to the last one in that I'm going to divide both sides by 10,000 just to get rid of that. So on the left side, I then have 1.353326 equals 1 plus 0.038 over 4 to the power of 4t. I'm going to go ahead and I'm going to simplify this right here. When I divide 0.038 by 4, I get 0.0095. When I add 1 plus 0.0095, I get 1.0095. All right. I cannot use the same method I used previously where I take a root of both sides because I don't know what the root would be. What could I type into my calculator? How do I make this something I can type into my calculator and solve? We have to use the opposite of exponents. We have to use logarithms. I hear the collective groan. I'm sorry. Logarithms, as a quick reminder, work something like this. If I said 3 to the power of 2 equals 9, I could rewrite that as log base 3 of 9 equals 2. They go 3 to the power of 2 equals 9. And this, if we put it like this, log base 3 of 9, we could put that into our calculator and say, oh, it's 2. We have to rewrite it this way to use our calculators. So 1.0095 to the power of 4t equals 1.35, etc. To rewrite that as a log, it would be log base 1.0095 of 1.353326 equals 4t. If you need extra help on logs, if you'd like review on that, there are links in the description below with log-specific videos. To enter this into your calculator, most calculators are going to use this function or key. It's going to say log base and have 2 parentheses and a comma. You put the base here, which is 1.0095, and you put the 1.3533, etc. there, and hit equals, and it spits it out. So if you're trying to figure out how to do this on your calculator to change that base, that's the most common way. When I type this in, whoops, when I type that in, when I type that log base in, the calculator tells me that the answer is 32. So 32 equals 4t. Then I divide both sides by 4, and t equals 8. This money has been there for 8 years. All right, so that is everything on this compound interest. Again, if you're looking for compounding continuously, that will be coming out shortly. And if you're looking for just compounding once a year annually, that's already done. Video is down below. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.